Scientists have long known that earthquakes generate several distinct sets of waves. They travel at different speeds, each spreading damage and destruction out from the epicenter. Modern city buildings in earthquake-prone areas like California are engineered to cope with such waves. Now, new research by geophysicist Professor Aris Razakis suggests that the San Andreas may offer a new and even more deadly threat. Razakis researches how earthquakes rupture along straight-line faults, just like the San Andreas, where it approaches Los Angeles. He creates his own mini-earthquakes, representing the San Andreas Fault by a hairline crack in a thick, transparent block. This special material shows up internal stress lines when it's lit by a laser. And the earthquake is triggered by a tiny explosion.
3, 2, 1, 0. The load has dropped, and the explosion was big enough that we even have a crack.
An ultra-high-speed camera capturing 10 million frames a second reveals a startling and newly discovered phenomenon. This frozen picture reveals stress lines speeding along the mini San Andreas in the milliseconds after the explosion. The cone to the left of this frame is a previously unrecognized type of shock wave racing along the rupture line from the earthquake's center. On a microscopic scale, it looks and moves exactly like the sonic boom produced when a supersonic aircraft such as Concorde breaks the sound barrier.
Because we also see Mach cones, lines that are emitted from the rupture tips as from the tips of moving airplanes.
And just like a sonic boom, it can be dangerous.
In the same sense that we hear the sonic boom from the Concorde, you're going to feel the sonic boom from the rupture.
The danger comes because many high-rises just aren't built to cope with extra stress from this newly discovered type of shock wave.
So if you are an old building, for example, you'll take one wave, you will accumulate some damage, and very soon after that, you will get very strong ground shaking because of other types of waves coming also.
The high-speed ruptures that Razakis calls supershear happen where faults run in a straight line, which might help explain a 100-year-old mystery surrounding the Great San Francisco Quake, the natural disaster which launched the entire San Andreas investigation. The overwhelming damage in San Francisco has long seemed surprisingly out of proportion to the 7.8 magnitude of the quake. And there's a particularly straight section of the San Andreas approaching San Francisco. So many scientists now believe that the damage was greater than expected because the 1906 quake had traveled at super shear speeds.